As for question 13, we have sec squared x minus 2 root 3 over 3 tan x minus 2 equals to 0. First thing to realize is that sec squared can be translated into tan x with our identity of 1 plus tan squared x. So we're going to translate that now. 1 plus tan squared x minus 2 root 3 over 3 tan x minus 2 equals to 0. We can simplify the 1 minus 2 into minus 1. So now we have tan squared x minus 2 root 3 over 3 tan x minus 1 equals to 0. We can see we have a quadratic now, as we have the squared and we have tan x over here. And what I would do to simplify first, always I do this, is I'd write tan x equals to y. So now we have a more normal looking quadratic. There's two ways we can go about this. First way is using the quadratic formula, minus b plus minus the root of b squared minus 4ac. With a being 1 y squared. A is 1, b is minus 2 root 3 over 3, and c is minus 1. When you do that, you would get y equals to root 3 and y equals to minus root 3 over 3. As we said y is tan x, we then have tan x equals to root 3, or tan x equals to minus root 3 over 3. Our second option, which we can use, is we can just try factorize it using this. First of all, we would know we use this one, the y, that it can only be y and y, because when we expand it, we get y squared, which is what we have here. We need to have only y and y, no other numbers. And now to get minus 1, we should realize that we need two numbers over here, which would times to give minus 1. And we have this number over here. So somehow there's a number related to this, which would, the number would add to give this and times to give minus 1. You should straight away think thirds, the rule of thirds. So if you have root 3 over 3 over here, you would put root 3 over here, because when you times them together, they give 3 over 3, which is the same as 1, which is what we need here. We need negative 1, so one of them has to be negative. And which one should that be? If we type them up in simple fractions, we have 3 root 3 over 3 and root 3, we have root 3 over 3, which is already there, and then we would have to make this 3 root 3 over 3. To get to minus 2 root 3 over 3, we would make this minus and this plus, as minus root 3 over 3, minus 3 root 3 over 3 plus root 3 over 3 would give you this. So we would put this as minus and this as plus. Let's see if our answers were similar. We had y equals to root 3. That equates to this, as when you expand this, when you equal this to 0, you get y equals to root 3. So those are our two methods. That's the same as saying tan x plus root 3 over 3 and tan x minus root 3. That's the same as that. So now we have these two. We can now work it out. So tan x equals to root 3. And using our calculator and cast diagram, our interval was, if I wrote it down, our interval was 0 to 2 pi. So as it's tan and it's positive root 3, these are the sections we need to find. So the inverse, tan minus 1 root 3, would give us a third pi. So this section is a third pi. Now we need to find out this section. And to do that, we're going to do a pi plus a third pi, which is 4 over 3 pi. So that is our answer when we have tan x equals to root 3. We need to remember we have this one as well, tan x equals to minus root 3 over 3. Using our cast diagram, as it's tan but it's negative, we're going to have to find this region and this region. So when we do the inverse of tan minus 1 minus root 3 over 3, we will get minus a sixth pi, which is the same as a sixth pi. That's this region, but we don't want this region. We want this region. And to do that, you're going to do pi minus a sixth pi, which gives you 5 over 6 pi. And then to get this region, we're going to have to do 2 pi minus a sixth pi, which should give you 11 over 6 pi, I believe. Yep, 11 over 6 pi. Those are your answers then. X equals to a third pi, 4 over 3 pi, 5 over 6 pi, 11 over 6 pi.